All right, there is no midterm for geometry AB. There is for other geometry classes, but not for geometry AB. You will still have a cumulative quiz like we had at the end of quarter one at the end of this quarter. Okay, that, what was it, 30 multiple choice questions, 25, whatever it was. You'll still have that at the end of quarter two, but no midterm during midterm week. All right, so you don't have to worry about that at least. All right, let's start this up. Let me see your knowledge on polygons, if you know what the names are back in the day. I'm not even going to ask anybody about three-sided figure. That's going to be, that's a triangle, yep. Where's my, where'd it go? Come on. Where is my, all the stuff I write with, huh? All right, I'll keep going here. Four-sided figure. And I know a lot of people say square, rectangle, parallelogram. Yes, those are all four-sided figures, but they're all types of quadrilaterals. Yes, for number four-sided figure. Quadrilaterals. There it is. Okay, so I got triangle, quadrilateral. Anybody know five sides? Pentagon. Nice, pentagon. This is usually where we drop off a little bit. Anybody know six? Hexagon, yep. Ooh, here's a tougher one. Seven. Two names you'll see. Septagon, which I'll use, and heptagon. You'll see both versions. So septagon, yeah, since I heard that first, septagon. All right, please don't say a stop sign for the next one. Octagon, yes. Ooh, here's where you get stumped. That is true. Nonagon. Are you just some like polygon wizard? Yeah.
No, I just learned these when I was in like second grade or something.
Ooh, second, huh? Second grade. I don't think second grade. My daughter's in second. I don't think she's learning nonagon. We're just learning how to add and subtract double digits right now. Nonagon. Yep. Decagon. Yep. All right. Just sorry about that. Decagon 10. Whoa! No more for 12? No, they didn't teach that in second grade? They're slacking. They're slacking. Anybody? Dodecagon, yep. So those are the ones you're responsible for. And then we get a little lazy. Some of you may enjoy that. Too harsh? Too harsh? Too soon? Sorry. Then we get a little lazy. 20 sides. We just say 20gon. Okay. There is an actual name, but I'm not going to get that ridiculous. We'll just stay to 12. So anything n above 12, we're just going to call it an n-gon. So however many sides, gone. Any questions on the names? You've heard of a diagonal before, right? But you probably only heard in a diagonal in a quadrilateral. You're just like, oh, you're probably like diagonal, connect the corners. Any of these could have diagonals too. Draw yourself a pentagon. 5 sides, best you can. I'm not going to judge. You can have diagonals in more than a quadrilateral. A diagonal is a segment that connects a vertice to a non-adjacent vertice. So if I connect this vertice to here, diagonal. I connect, let me do a different color, this vertice here, diagonal. That's a diagonal. Doesn't have to go corner to corner. It can be in any figure. It just has to connect 2 non-adjacent vertices. Well, what if I connect 2 adjacent vertices? That's called a side. Okay, everybody good? That's called a side if you connect 2 consecutive ones. So everyone's good with the diagonal because that leads into these 2 types coming up. All right, I don't think you have heard of these before. Polygons can be convex, concave. Familiar? Yes, no? No, that's fine. Convex. That's probably what you've dealt with your whole entire life. Are convex polygons, meaning every single diagonal is located inside your polygon. there's no diagonal that can be drawn outside. So everyone see our pentagon that I have up there? That's convex. That's a convex polygon. There's no way I'm doing a diagonal on the outside. What's concave? Ooh, a diagonal can be drawn on the outside. So what the heck's that going to look like, right? Anybody ever seen the little arrows here? That's a concave polygon. Well, people are like, that's not even anything. What's that called? 1, 2, 3, 4, 5, 6, 7. This is a septagon right here. It's got 7 sides. Why is it concave? Do you see a diagonal you could draw on the outside? There you go. You could also draw this one on the outside. That's concave. That is concave. I always think of it as part of the polygon is kind of caving in on itself. So I did have a nice 7-sided figure, but it kind of caved in on 2 spots. Convex versus concave. Any questions? Here's where we're going to get crazy now. How many degrees are in a decagon? No clue. How many degrees are in a 30-sided figure? No clue. You're about to, though, in your groups. You're about to. So take a look at the chart I have. You and your group are going to examine 5 different figures. The first 2 we'll examine together. The first one's a triangle. Triangle. And as you guys know, how many sides in a triangle? We got 3, right? Now it says number of triangles. Well, that's meaning how many triangles can be formed from one triangle? 1. And what's the sum of our interior angles? Sum of the interior angles of a triangle? 180. Yeah, we're good. We're good. That's pretty basic. All right, next one we're going to examine is a quadrilateral. How many sides? Quadrilateral. 4. Okay, 4 sides. Now, here's what I'm talking about by number of triangles, so you know when I leave you to your group. Here's my quadrilateral. Coming from one vertice only. You're only allowed to start at one vertice and go to others. How many triangles could be made? That's the only, right? I can't draw any other diagonals in, right? So how many triangles? 2 can be formed coming from one vertice. 2. How many degrees are in each triangle? Ready? Watch. 180. 180. How many total degrees? That's where 360 comes from if you're interested, because it can form 2 triangles. So that's what you're going to do for the next 3 I put up here. How many triangles can be formed from one vertice? And then times 180 to give me the number of degrees in the total figure. So you and your group right now, you're going to do a pentagon. You're going to do a hexagon. And then finally look at an octagon. And I hope you find a pattern between the number of sides and the number of triangles that are going to be formed. Okay, so go ahead, talk in your group, draw yourself whatever diagrams you got to draw. How many triangles? And then multiply each of them by 180 to figure out the number of degrees in each. Okay? How many sides, how many triangles can you find? All right, what do you say we fill in the rest of it? And you guys tell me if there's a pattern or not. Pentagon, we know there's 5 sides. Anybody find the number of triangles formed in a pentagon from one vertice? 3. So that means 3 times 180, there's 540 degrees in every pentagon, correct. How about hexagon? 6 sides? How many triangles? 4. times 180. How many degrees in a hexagon? 720 degrees. A lot, right? And then what about we jump to octagon, which is 8. How many triangles? 6 times 180, 1,000. Whew. 80 degrees. Do we see a little pattern existing? All right, so what if I go here now? Something you can't draw conveniently. How about a 30gon? 30 sides. Could you still find the number of degrees in the interior angles? How many triangles should it form? 28. 2 less, right? Because everyone, number of sides, the number of triangles formed is always 2 less. So 28 times 180. Woo, 5,040 degrees in a 30gon. So now we see how we can find, no matter the number of sides I can give you, you should be able to find the sum of the interior angles. Now let's officially write it down. All right, my polygon angle sum theorem. Here we go. Sum of the interior angles. Let's see if you guys we can build it together. What's the big thing you need to know about your figure to find the interior angles? Look at your chart. What was the big thing you guys need to know? Well, how did I get, okay, let's keep backing up, Romeo. How did I find the amount of triangles? I need to know the amount of sides. Okay, so I'm going to put in this formula the variable n, which is going to be the number of sides. All right, build it, build it. What did I have to do with n? You guys found the number of triangles after that. How? -2. And then that gave you the number of triangles, and then you had to do what? There you go. You just built that formula by yourself. Settle down. So I take the number of sides -2, and I multiply it by 180. That will find you all the interior angles added up. Okay, you and your group. I don't need to practice this with you. Go. You and your group. Questions 1 and 2. See what you got, and then I'll call on people. Questions 1 and 2. Okay, I need more than answers. What did you do to get to the answer? Talk to me here. Okay, let's start with a 100-sided figure. Imagine what that would look like, huh? 100-sided figure. Tell me what you did to get to the amount of degrees on a 100-sided figure. Let's hear from 16.
17,000.
Okay, how'd you get there?
So I did 180, and then I did and then like in the parentheses, 100 minus 2.
Good. N is 100. Figured that out. What was it? 17,640 degrees. Perfect. We're all good there. And then number 2, how did I find the missing angle now? How do I find the missing angle? I have 4 of them, but I need 5. Number 2, how do I find the missing angle? 1, George, what's the deal?
You add all the numbers inside the pentagon. It's
a pentagon first, right? 5 sides. How many degrees in this pentagon?
540.
540 degrees total. Go ahead, keep talking.
Then you just subtract that number from 540.
There you go. And what'd you end up with, boss?
103.
There you go. Questions? Everyone all right? How to find what they all add up to inside? Because now we got to go outside. What do all the exterior angles add up to? So here's what you're going to do for me. Let's see. I got 1, 2, 3, 4, 5, 6. Perfect. I'll do group 1 is this combined group right here. Group 2, that combined group right here. And group 3, this combined group right here. Right? So everyone knows what figure you're responsible for. What you are going to do is you are going to find every exterior angle and add it up for me. So group 1, for instance, 85 is the interior. What's its exterior? 90 is the interior. What's its exterior? 120 interior. What's its exterior? And then add them all up. I just want to know what they all add up to. So go ahead right now. Go ahead and do that. And then converse in your group. Make sure you're all on the same page.
You got all 3.
What's the relationship between the interior and exterior? They should be supplementary, hopefully. The interior and exterior should be supplementary. They form a straight line. Find all of them in your figure and add them all up. Make sure everyone in your group agrees. Compare, compare.
360.
Group 1. Group 1. 360 degrees. They should all add it up to 360, huh? Oh, okay. Group 2 at, where we go? What do we got? Also 360, huh?
That's crazy.
And group 3? Also 360. What's the point I'm trying to prove? Does it matter the number of sides? No. I don't care how many sides it is. The exterior angles will always add to 360. Done. It doesn't matter. There's no special formula. The sum of the exterior angles will always equal, yes, 360 degrees. No formula. All of them will always add to 360 no matter the number of sides. And you guys just proved that. All good? All right, let's try out some algebra questions now. Let's rock and roll. How about 3? Read it through. Discuss it in your group. You got about 45 seconds. Maybe less. Okay, I think we've got enough time. 36 sides. 36 sides. What's the sum of the exterior angles going to be? 14. Sum of the exterior angles? Yep. 7. Sum of the exterior angles? Yep. I don't care what I change that 36 to. It's always going to be 360. Any questions? So we know interior, 180 times n minus 2. Exterior, always 360. One vocabulary term I got to talk about and we're done. And we got to practice. Regular. A polygon's regular. Any thoughts? Anything you want to throw out? If you know a hexagon is regular. An octagon is regular. What do you think? You're probably going to be right. Never mind. I said anything, but Molly?
Are all like the angles and stuff equal?
Let's first stop right there. All interior angles are equal. Or congruent. So if all the interiors are equal, that means all the exterior angles are congruent. And there's one other piece I want to throw up here. What else do you think are congruent? Sides. All sides congruent. Correct. You don't have to write this on your paper. I just want to give you this visual. Let's say this pentagon is regular. good? And there you go. Regular pentagon. Make sense? All right, I really just don't want to stand up here and say, hey, this is how you do it. I want you and your group to think about it. We got plenty of time. So now assume pretty much we're going to be dealing with regular polygons from here on out. Okay, from here on out, regular polygons. It's got 20 sides, this regular polygon. Find the degree measure of one exterior and one interior. Not the whole thing. I just want one interior and one exterior. So your final answer shouldn't be 360 for the exterior. I just want one of them now and one interior. Talk it over in your group. Here you go. You already know it's got 20 sides. That's all I need to give you. Find one interior and one exterior based on what we did already today. Think about it. Think about it. I don't want to know the sum, but that may help you. I want to know what one is.
Wait, they all add up to 360.
Because you gotta keep the sum for all the angles. Right. But then you would divide that by 20, and that's like.
So then it'd be 360 by
The
8.
exterior angle.
And then you
One.
divide by 20.
Good thing about this is we could do this a couple different ways.
If it was the total size of it, that
All right, ready to talk? Okay, guide me through how you found you start first, interior or exterior. I'm going to have two people. Somebody's going to do interior, somebody's going to do exterior. So you pick what you want to start with first. 4, let's roll. Via, do you want to do the interior or exterior?
Yeah, I don't mind doing the interior.
Okay, go ahead. How'd you find the interior?
I don't know, just did 180 times 20 minus 2.
Okay, so let me just, first thing Via is doing is finding the sum of all the interiors, right? So you did 180 times 20 minus 2. And what'd you get for that?
3,240.
3,240?
Yeah.
All right, and then you did what with that number?
Yeah, and after that, divided up by 20.
Then, there you go. So you divide by 20. So one interior angle is 162. Nope. I said no. 162. Everyone's good. How we got that? We all good? Good job, Via. All good? Okay, next. How about the exterior? Could be done a couple. Now that I know the interior, the exterior can be done a few different ways now. Talk to me. 8.
Oh, for the exterior, I did 360 divided by 20.
Yep, 360. That's the sum. Divided by 20 equal exterior angles. And what do we end up with? 18 degrees. Perfect. Couple things. What's the relationship between every exterior and interior angle? They always are what? So add to 180. So the other way I could have done this is, all right, Via found 162. 180 minus 162. Done. 18. Or did anybody start with the exterior? You could have started with the exterior and subtracted that from 180. Okay, either way. All right, let's keep going. Now I want you to find the number of sides. If you know one exterior is 120. How many sides does this figure have? So this should be a little bit quicker than 4. All right, so if it's got 120 degrees, one exterior, and they're all the same, how many sides is this bad boy going to have? No guess and check either. No guess and check. You already know the exterior is 120. How can I find the number of sides?
It should be into
Exterior.
and then that's
Exterior 120.
60, 180 about 3.
And then one is one from the
120 divided by 180.
Ooh, come on now, guys. Come on, come on. Got to show some work too. Can't guess and check. All right, let me turn it over to one of you guys. Uh, 11. We don't have one, right? 22 in the house, or nope, no 22 today. 15. Exterior angle. What do they all add up to? Yeah. And you already know one of them's 120. So how many 120s do I have to get up to the 360 they add up to? 3. 3 sides. All right, that was it. 3 sides. Everyone okay there? They all add up to 360 divided by 3, or divided by 120. All right, now let me challenge you even more. Instead of giving you the exterior, now the interior is 160. How many sides? Don't guess and check either. Don't guess and check. How many sides in this if one interior is going to be $1.60? Talk it over in your group. There's different ways to approach this. Talk to me here. How am I? If I give you the interior is 160, how do we get to the number of sides? 9. Let's roll.
I did 180.
What's that giving you?
20.
Well, what does that 20 represent?
The interior. No.
Interior was 160.
Sorry, the exterior.
Okay, everyone. Hey, I'm turning this problem into number 5 now. Oh, the interior is 160, you say? So the exterior is going to be 180 minus that. So now the one exterior is 20, and now I turn it into problem number 5. What am I doing with that 20, Lisa? 360 divided by 20 will give me 18, right? 18 sides. I'm telling you, anytime you can deal with an exterior angle, do it. Why? I already know what they always add up to, 360. All right, one more, you and your group. Now I'm telling you all the angles add up to 2,880. What's the number of sides without guessing and checking? What? All the interior angles add up to 2,880 without guessing and checking. How many sides does it have? How many sides does it have? 2,880 degrees inside. How many sides without guessing and checking? Don't you have a formula that gives you the sum of the interior angles? And I think you know what that formula is equal to now. So I don't have to guess and check. We just found an 8-sided figure with 1,080 beginning of class for an octagon.
Okay, yeah.
Some of them see.
Wait, so well,
If there's 8 sides,
I do.
Okay, let's go over this because I see got a handful of us that are not picking this up, which is fine. The sum of the measures of an interior angle of a polygon. I gave you a formula for that at the beginning of class. What was that formula? 180 times n minus 2. And now what's this formula equal to? Oh, that's the sum of the interior angles, which is equal to 2,880. And I'm being serious about this because I see crazy things every year when I do this problem. How do you solve that for n? Because I see kids do a ton of crazy things that are incorrect.
Okay, so what you want to do is that you want to multiply 180 times n and 180 times.
So you're doing distributive property. Okay, first thing you can do, yes, you can do the distributive property, or I don't know if anybody got rid of the 180 by dividing both sides by 180. You can do that too. All right, those are really your only two options. Don't be adding 2 over. That's a no-go. All right, it's either divide both sides by 180 or distribute the 180. I don't, either way. So I'll do the distribution. 180n minus 360 equals 2,880. Add 360 over. I have no clue what you get here. 1,800? No. What do you get here? No. When you add 360 over. 3,240. Then you can divide by 180 and get 18. There's a purpose why I had you guys do these at the group instead of just me doing through these. You're going to have to grind through these tonight. I can't just if I walk around tomorrow and there's just answers, I know you just copied the answer key because you guys are seeing the work most of these take. And these are the same exact questions you'll see tonight. Use your notes to answer them. We did a problem just like that. Go back to your notes and take a look at it. We'll see what you got tomorrow.